So I'm happy to introduce R. Tyler Croy. He's an engineer with Lookout Security and has done a number of things with both Puppet and Jenkins, which I know I use every day, so I'm personally grateful. So R. Tyler Croy.
Go back one. There we go. I think there's quite a few people here. There's a good fragmentation amongst the seats. So anyways, I work at Lookout Mobile Security. As an app developer, my full-time job is not infrastructure or operations. So a lot of the things I'm going to be talking about today are more my skew or my view on test driving operations. And some of these things are kind of lofty concepts, but a lot of it I've put into practice to some extent. So I'm not sure how many people here are full-time developers. Like, I wouldn't be able to see your hands if you were raising them anyways. But there's a couple whistling, as you can tell. It looks like I need to go full screen with this. There we go. So there's a couple different kinds of testing that come out of the software engineering world. The most basic, which you're probably already doing, is manual testing. And my favorite tool for doing this is using Vagrant and just standing something up, poking around at it, making sure it looks correct, tearing down the machine, committing my code, and moving on with things. There's also unit testing. And unit testing doesn't really get used all that much in the Puppet community, but it's a very important part of the Ruby community. And unit testing, in a nutshell, is if you just take a single method, here's what that method should be doing, write some tests for it, make sure it does that thing, and move on. Going up a level, and I view things like manual testing kind of at the bottom of the totem pole. Then you've got unit testing, and then getting more complex and a little slower, there's integration testing. And in Ruby code, this typically means you're pulling in different modules or different gems and making sure that the interactions between these things looks correct and does the right things that you would expect from them. At the outermost layer, though, there's acceptance testing. And acceptance testing is something that's been talked about and used for probably 20 years now. But the general gist of it is specifying your acceptance criteria. If you build me a gem, I want to tell you up front, here's what I expect that gem to do at a high level. I actually don't care about the nitty-gritty bits of what it does internally, but the API that I'm going to interact with is going to be defined through acceptance testing. And once those acceptance tests pass, then the work is pretty much done because we've met the acceptance criteria. These are kind of the various buckets in which testing generally falls. You'll hear terms when you look through articles around systems testing or functional testing. There's a lot of different ways you can cut testing up. Google has done some posts on their testing blog before that really characterize it quite well, where you've got slow testing, which is acceptance testing. You've got kind of medium, mid-grade, it kind of needs some database resources, it's a little bit slower, and then your unit testing, things that run blazingly fast, you can run in 10 seconds, get really quick feedback. And that's where test-driven development comes into play. The idea behind test-driven development, actually, before I go into that, I'm going to be talking about test-first driven development. And there's an interesting kind of split in the testing community between testing while you're writing things alongside and starting with the tests. And both of those, technically, however you want to cut it, do fall under test-driven development. But I'm really talking about test-first-driven development here. And the whole, the great grand idea from Kent Beck was that you would just write your test first that says, here's what the method should be doing. Then you would go in and make the code actually make that test pass. And it forces you to think about what you expect that method to be doing at sort of the outset, instead of along the way figuring out, oh, I've got all these side effects that I need to account for, and I need to test those as well. This is where the whole notion of red-green testing comes from, thus my fancy stoplight. You start with your red test, then you make it go green, then you add another red test, you make that go green, and on until you eventually get to where you've got something that you can commit or even release. What a number of people really consider to have superseded or more refined the idea of test-driven development is behavior-driven development. And it's a little bit of a semantics argument, in my opinion. When you talk about behavior-driven development, you're really talking about what should be happening here, as opposed to very specifically saying, if I pass this a string, here's what I should get back. And this is closely related to, but not necessarily identical to, acceptance test-driven development. And this one's probably of all the Ds, including Jordan's hate-driven development, my favorite driven development is you start out specifying what's the thing we're actually building here? Why are we building it? Who are we building it for? And then you specify these acceptance tests, and then you can drill down deeper in figuring out how to actually implement that. But you start by specifying what are we actually trying to accomplish here, instead of building, just focusing on your gem or your Puppet module. So I think that's neat, I guess. It's become fairly commonplace in the Ruby community. I think for better or for worse, Rails has done a great job of encouraging testing within the Ruby community. Other software engineering projects use test-driven development quite successfully, but it's not something that I see happening a whole lot in the operations community, especially when you start talking about infrastructure as code. The first thing that you say when you say infrastructure as code to me is I want to see the tests. Like, I want to know how this Puppet module actually does the thing that you're telling me it's doing. And the only way that you can really communicate that to me, and I'll be certain of it, is with tests. So I want you to imagine the following scenario. And I'm guessing there's a lot of people whose day jobs is really sysadmins, so this should hit home for you. Developers you work with, like this guy, come up to you and they've been building this web service and they really want to deploy it. But they didn't tell you anything about what's going to be going into it or what they need. So you've got to go through and start figuring out what they need and start building it, because naturally, as we're prone to doing as developers, we ask for things way too late. So what do you start to do? Like, imagine you start with a blank slate. Where do you start to put the different components into play to build up a system that's going to meet that need? You could just go around the Puppet Forge and just cherry pick modules, throw them into one repository, and hope that works. Maybe push that out to a staging server and deploy onto some nodes and make sure that everything kind of looks correct as you tinker around with the system. You could pull those into your local Git repository and maybe use something like Vagrant and do what I've done a number of times and just stand up a machine, look at it, make sure it all looks correct. So what's interesting about that workflow to me is I've done it so much, and every single time I've done it, I know I'm doing something wrong, and I have that uncomfortable feeling that I'm not going to like what I've done today in 6 months' time, or even 12 months' time. And I've looked back on some of my own Puppet modules and thought, the hell was I thinking? And I don't remember what I was actually thinking or what I was using Vagrant for or what I was actually looking for. And it's not really a maintainable workflow if you want to scale a system from, say, one developer or one ops engineer or infrastructure engineer to 10 engineers, or even go from, this is going to be a month-long project to a 6-month-long project. I've forgotten that I had this slide in here, and I don't remember why. But the manual testing is probably why Daddy drinks, especially when you come in and you see someone else's Puppet code. I've worked with a number of people before who have committed really great work, and we have systems in production that work fine, but they couldn't tell me, and I couldn't tell what the hell they were trying to do or what they were trying to accomplish at the time. And this is something where tests can be really useful. And so I'm going to try not to be too prescriptive here. I don't want to tell everyone that they should be doing this, because some of these ideas are not as battle-tested as some other things that I've talked about before. But I want to take some fairly common practices that we practice in the Ruby community and apply them to Puppet. Firstly, we're going to be using, for everything I'm talking about from now until I get kicked off stage, is going to be about Puppet modules. I think Puppet modules are the right layer of abstraction to start diving down on tests. Secondly, I'm going to be talking about a couple tools, Cucumber and RSpec, to do those tests. And the reason that I'm talking about both Cucumber and RSpec is because I think they enforce a good level of separation between talking about what you actually want to implement, what you want to provision on the machine, and then specifying the overarching goal of all these things. And this workflow is definitely sort of away from the direction of what I would consider a traditional sysadmin role. But the resulting Puppet modules that come out of this workflow should be more reusable, easier to refactor, and stand the test of time better than something that was cobbled together to meet some customer needs and then forgotten about. But it's just, like, why go through all that trouble? If you've got these developers like me coming up to you to say, we need to ship this now, like, why would you take the extra effort to make sure you've got all these tests? Because infrastructure is code. And I've personally never written code that has died when I left the project. It always comes back to haunt me. So I would imagine you've had some similar experiences with Puppet to where you've done something, say, in the 0.25 era when Puppet was a little different, and had it come back 2 years later and really bite you in the ass. So I wanted to refer, I have to include a handwritten slide at least. I made this really important graph to kind of describe why we need to do this kind of testing. If you find failure sooner on your laptop, it's actually really cheap to find that failure. You can iterate on it really, really quickly. When you start to push that out to the staging environment, then it becomes a little bit more expensive, time-consuming. You might actually have issues that affect other people that are trying to use that staging environment at the same time. And then if you get into production, things get really, really fucking expensive really, really quickly. Especially if you make such egregious mistakes that you, I don't know, remove Ruby from production host accidentally, or drop tables, or manipulate data in any form or fashion. But I want to preface some of the testing discussion by saying that production is not necessarily going to be bug-free. The test will not prevent you from pushing out bad code into production. Sometimes things are going to break, and this is why you've got to kind of anticipate failure at all levels. And tests aren't going to stop you from breaking things. But with testing, we actually get a clear definition of what we're trying to build. And the reason I think that's important, and bugs getting out into production is super expensive, but if you actually have this clear definition of work when you start, you can avoid building things you don't really need to build. You don't have to go down the path of adding all of this support, pulling in all these modules, combining them, and only finding out that you actually didn't need to provision that kind of Apache, or you didn't need this extra work to be done at all. By starting with those tests, you know what you're building from the very beginning. So I may have done a shitty job of this in sort of selling you on testing. It's one of those things that I hope you all love testing. It's hard for me to explain because it's something that it's so fundamental to the way that I do work that it's a little bit difficult for me to sell people on it. So let's start with a couple tools. I'm going to be starting with Cucumber. Some people hate Cucumber venomously. I find Cucumber to be quite useful. And RSpec Puppet. And if you go to the GitHub drink up and you find Tim, shake his hand. He did a really great job putting together RSpec Puppet. But what we're going to use RSpec Puppet for is the unit testing of modules. And it actually took me a long time to understand why unit testing of modules was important, or why I would even want to bother, because I could look at the manifest and I could say, well, no shit, I'm going to provision Apache. No shit, I'm going to be doing all these things. Why would I want to also specify that in RSpec Puppet? So let's jump out to the stakeholders, and let's start from the Cucumber and work down. The stakeholders are kind of generally the consumers of the work that you're doing. And in Cucumber, this really starts out as just simple metadata in the file. And I'm going to start by talking about developers as the stakeholders. Because at the beginning of all of this, I said the developer had come to you and said, hey, quick, we need to deploy this thing. I need to get this out into production. And so we say, as a developer, I want these web hosts to be provisioned to run my super awesome application in order to stream PuppetConf to millions of users. And I've thought long and hard about this, and I've kind of gone through thinking about developers as the stakeholder for operations work, and it doesn't really fit for me. As a developer, I don't actually care how you do your work. What I care about ultimately as a developer is that the application works at the end of the day. So I'm going to change as a developer to as an operations engineer, because I think ops should be the stakeholder for a lot of operations work. Mostly because ops suffers from shortcuts taken by ops. Developers don't generally suffer from that. So the work that we're going to do is for operations, and we're going to document it as kind of for operations. And the reason that I use Cucumber in this case is because this becomes executable documentation, which is something I find to be a rarity in infrastructure code. And we just start from here, and let's go ahead and start building a couple scenarios. I didn't want to explain Cucumber too much. You can read all about how it actually works. But this is the test. This is what the documentation looks like. We just say, given an empty host, when I provision it, then port 22 should be reachable, and we shouldn't be able to do passwordless logins. That's just one sort of criteria we're going to specify from the outset for all of our app hosts. We're also going to add, we want all these app servers that we're going to provision to be added into the load balancer. So we're going to specify that up front as well. And we want to make sure that when we provision these hosts that are specifically web hosts, we want them to come into HA proxy, and we want them to be added to the service group in Nagios. Now this scenario is actually what I'm going to drill down in, because we just want to provision a basic web host. Forget Nagios, forget HA proxy, forget any of the other security things that we're going to need to consider. At the end of the day, we really just want to stand up a web host. So when I provision the host, then it should be running a web server, and it should be responding to the requests. This doesn't actually tell me anything about the application, but it's going to inform the decisions and the modules that I'm going to write further down the line. And so this is all well and good, like just kind of simple English. Like anyone in here could write this, and it would look just like that, and it wouldn't do shit. So let's kind of put it into practice. The way that Cucumber works is you start putting code behind these steps. So given an empty host is kind of boilerplate, just setting the stage, we're just going to start with an empty VM on EC2 or with Vagrant. And there's not really much to say there, so let's move on. While we're really talking about testing Puppet modules underneath, what I'm actually interested in from the outside is that this host is going to be a www node. I don't actually want to prescribe what modules get written underneath or what components come together to do this. What I really want this node to be is a www node. And so I'm going to drill further and say, this is what that node's probably going to look like. I'm going to include this SSH stuff, our custom application module, and then the Apache module. And that's what the node's going to look like in my sort of worldview of what this application provision is going to look like. So we now get to drill deeper. And for this example, I'm going to drive into one specific module. I don't want to touch SSH or the stream app module. Drive into Apache, because I think everyone here kind of has a vague sense of what Apache does. We're not just going to cheat, by the way, and grab the Apache module from Puppet Forge. We want to build this thing ourselves, and we want to use some tests to do it. So this is where RSpec Puppet starts to come in. And we can start by just scaffolding things out. We haven't written any Puppet thus far. We're just going to add a simple RSpec test. And at this point, I don't actually need to do anything. If I run RSpec Puppet at this point, it's going to complain that the Apache module doesn't exist in my tree. So then I can go in, and I can define the Apache module. And I run RSpec again, and it passes. And this should all be very, very quick. And this is the kind of basic feedback loop of test-driven development. So now I'm going to jump back over to RSpec. And I'm going to say that my Apache module really should contain the package Apache 2, because I'm on Ubuntu, and that's what it's called. And then I run it again, and it fails. So I go back to Puppet, and I say, Apache 2 should really be installed. And at this point, I can run again. Everything looks great. Everything's green. And I can come back up to Cucumber and run my integration tests, or excuse me, acceptance test again. And if we just pretend for a moment that the Apache package on Ubuntu doesn't auto-start services and do all this other nonsense, then the test would fail. Because we said, we're going to classify this as a www node. We're going to provision it, and it should be serving web requests. And port 80, I guess, should be open. So we need to add a service. And so we're going to go back to RSpec, and we're going to say, this Apache module really should contain the service resource, and it should make sure that that service is running. And when I run RSpec here, it's going to fail, of course. So I need to jump back to Puppet and add the service and get it running. And so what's going to happen when I actually run this in production is, or in that acceptance test, is sometimes it might succeed, sometimes it might not, because there's no actual relationship that's been set up in the graph here. And the reason I try to focus on sort of this acceptance test level testing versus RSpec Puppet is because RSpec Puppet can't really guard you from directing the graph the way you should be doing it. Only compiling the catalog and actually running it on a machine will you ever be certain that what's being provisioned is what you would expect. So we know we need to set up that relationship. We can jump back to RSpec, and we can say, the service should require that package to be present first. And then we can add that back to Puppet. And when we run RSpec now, it's going to go green. And then when we run our acceptance tests, they're going to go green. And at the very least, we've succeeded at implementing the first scenario, which is I should stand up the application, or I should provision a host, and it should be running a web server, and that web server should be responding to web requests. And that's it. I mean, all that other stuff, put it off to the side. This is the essence of test driving with Puppet, at least for me. The acceptance test part, you could do a number of different ways. But the sort of specifying things at the outset and then drilling deeper into RSpec Puppet and then stepping back out and running and compiling a catalog and provisioning a machine, that's the only way that I've ever seen thus far. I mean, I'm sure there might be other approaches. That's the only way I've seen test driving operations code really work out. And the benefit of going through this is we've kind of specified out front what these modules should be doing. And so any consumer of this Apache class should be able to always rely that we're at least doing this stuff because it's specified and it's tested. So that's neat, I guess. I'm going to go ahead and jump into a demo because I'm not sure how convinced of RSpec Puppet anybody is. And so we'll see how this works. One of the places that RSpec Puppet has really kind of become important is when you start maintaining a module that supports a lot of different versions of operating systems or takes different paths when you're provisioning a host with these facts versus these other facts. So what I'm going to do is, where am I? Sorry for that blink. This all works well and good on Ubuntu. So I'm going to say on Debian family hosts. I'm going to pull this up here, format this correctly, all nice. What RSpec Puppet actually allows you to do is define facts, but also parameters that you're going to use. So I'm going to say the facts for these tests are going to be just in a simple Ruby hash. I'm going to say for the OS family, Debian, I can type, this is what we should be running. And so when RSpec Puppet is going to run this, it's going to supply the Debian fact for the OS family fact. It's going to supply the Debian value. To where if you do anything like, in one case you would include the Debian module, in another, the Debian class. In another case you would include the Red Hat class. You can then test this and make sure that everything is doing what you would expect for this. And so we actually haven't done anything all that interesting here. So let's do on Red Hat. This is really hard to type under pressure. Especially, I've got to look down here or look up here to type this because I don't have mirroring on. It's really challenging. So I'm gonna cheat and I'm gonna put all of this under one big if statement and hope no one yells at me from Puppet Labs for doing this. No? No? Okay. I'm going to run these tests, and they run just fine. They run pretty quickly. Disregard all the warnings. Pretend those don't exist. And I'm going to copy and paste my test because you can do that in demos. And I'm going to say on Red Hat. Red Hat. And we'll run these tests again. And they passed. Why did they pass? Because no one told me I'm doing things wrong. I'm really used to doing that with other people. Is I need someone there to tell me I'm fucking something up, especially in front of other people. So now when we supply the Red Hat fact to our new Apache module, it's going to fail because it doesn't know what the hell we're supposed to do with Apache. So I'm going to go in and I'm going to say, I think on Red Hat it's HTTPD? Yeah. All right. I'm going to make this pending for now because I don't care. Run this test again. Naturally, the one thing is going to fail, and so I'm going to come up and back over to Puppet and implement this. Again, cheating and just doing an if statement. Red Hat package, HTTPD we called it, yeah. Installed, great, yippee. Cool. So that's that. I'm going to delete this other example because I don't want to go any slower than I am already. So at this point, the module supports installing the package correctly on Red Hat OS family and on Debian OS family machines. And I can be certain when I push this to Forge that it's at least going to continue to do what I've told it to do, depending on the facts that are kind of specified in RSpec. You can go one step further, and I saw Kelsey give a good talk where he's talking about parameterized classes and some other things. And let's go with a custom version. Let's add some parameterized class stuff in here. And just like you can let facts, and there's good documentation on how to use RSpec online, so I'm not going to touch that all that much. And let's say we're going to pass the version in as, I don't remember any Apache versions. Let's say 1.3, because I'm sure that works on Red Hat. And we're going to say it should contain package, HTTPD, yeah, with ensure 1.3, because that's how you do versions. Great. And so that's going to fail because we've specified the version that's going to be going in, but our Puppet is just doing ensure installed. So now we can start specifying the parameters that are going to go into our parameterized class. We'll do version installed first, make sure I didn't break anything with that. I broke a lot of things with that. What did I break? Ah, thank you. So now I still only have my one failing test. And in the case of Red Hat systems, I can see a bug already. I'm going to continue through and let it fail again. Here's seagulls, or am I having a stroke? So it's going to fail again because we didn't specify our facts here. And we're only doing this for Red Hat right now. So let's change this to Red Hat. And the reason that this is important is because you can set up your module to handle facts or various things in the Puppet ecosystem and take different behaviors and make sure that they are consistent about handling those behaviors. And so if you want to maintain a module on the Forge, did I miss something else? Yeah, I missed another curly. I'm really great at programming in front of 100 people. If you want to publish stuff up to Forge and you want to support CentOS, Solaris, Debian, and all these other things, it really helps to dive into RSpec Puppet and set up tests for these things. Because then when you receive pull requests or have people complain that something's broken, you can scaffold it out in RSpec and actually go in and fix it quite easily. And so in, I don't know, a few minutes, I've built a very, very simple Apache module here that's going to work on Red Hat family systems, Debian family systems. And I'm sure that it's going to work because I have tests. And I think that's pretty neat. So that's really like the gist. Like if I could boil down anything from this talk, it would be that when you push Puppet or when you push modules to Puppet Forge, if you don't have RSpec Puppet tests or if you don't have any tests whatsoever at any layer, then it's going to become really difficult to maintain that as time goes on, as people make requests for things. And so that's the importance of test driving out some of these Puppet modules. The side benefit is that you start to think about what your module should actually be providing. Like, what is important to put into Apache? I mean, I can see going in and adding in support for virtual hosts, adding defined types, and I would want to add tests for those. When you start to go into application land, there really shouldn't be anything from my stream application module that's dependent on anything in the Apache module unless those dependencies are made really explicit. And vice versa. I've seen a lot of Puppet modules I've written a lot of Puppet modules where I bleed variables across and I cross all the streams and all of these cluster of modules are all interdependent on one another. So when I first started talking about this with Tim, who created RSpec Puppet and IRC, I started talking about this grand vision of like, what if you could acceptance test drive your tests or your Puppet modules and provision things and do all this work? And he asked about monitoring. And this is something I still haven't actually figured out. There's a couple of tools that will run Cucumber tests or run these sorts of things in production to make sure that your production Puppet runs are doing what you would expect them to. And I can see the reason why you would want to do that, but it's difficult for me to imagine how that would actually play together. So there's some other tools that can really help drive this home. Recently, kind of between when I suggested this talk and when I ended up writing it last week, Puppet Labs released the Puppet Labs Spec Helper. And this is a great starting point that helps centralize a lot of common things that you're going to need to do between modules that you're testing. If you're looking at doing monitoring with your testing in production, there's a couple modules, or excuse me, a couple gems that really help with this. One's called Cucumber, and the other is Cucumber Nagios. And I haven't actually deployed these into production, so I can't tell you all that much about how well they work out. But they're really interesting projects, and I'm hoping to see in the next 6 to 12 months how people start to employ them and use them for actual production stuff. They might be doing it already, and I just don't know. Naturally, Vagrant, if you're going to be doing any level of manual testing, Vagrant is just far and away the best choice you can go for that. I'm going to skip talking about the thing that I wrote just because I don't want to talk about it right now. I've written another tool that I think Mitchell's going to make obsolete really soon now with Fog or EC2 support, VMware support in Vagrant. So forget I said anything about this and just go pressure Mitchell to release some of his work. I think given the time, I really went way faster than I thought I would. Of course, my demos all went swimmingly, so I didn't expect that, and I accounted for a lot of extra time. Are there any questions that I could answer about this? It would be better. They'll yell at me if you don't, and withhold my beer.
I had a question about using the RSpec tests to test for things like stored configs or exported resources, things like that.
So the way that I've always deployed Puppet has always been masterless. So I've actually stayed away from stored configs and any exported resources. I think if you go to Zeke's tonight and pin down Tim and ask him how the hell that works, he's done some amount of work with it, but I personally can't speak to it very much because I've never tried. There's a lot of things in RSpec Puppet that you can do that either someone hasn't asked about or Tim hasn't written down the documentation for. So it's just a matter of going and kind of cornering them and getting your answers. I can't see anything above here. Are there any other? Oh, yeah.
So for the test or for the ops monitoring part, were you talking about examining the compiled catalogs or as part of a compliance testing sort of thing? Because one of the problems that I've had with RSpec was I wrote this when I was learning how to do it. I wrote this test, and RSpec tested my my module just fine, but I never tried to combine the submodule combined with my other module, and everything blew up because I had duplicate resources. So
I think right now, I don't think that there's great solutions out there. I was talking with some other guys earlier, and the work that Dom's been doing at Puppet Labs around the Puppet acceptance and making that test harness kind of bringing that somewhere closer to RSpec Puppet to where you can actually do kind of making sure that catalogs are compiled correctly or that everything kind of integrates kind of on the system is something that I think is going to be built out and better defined in the next 6 months. I'm hoping if I mention this on stage that it'll pressure some Puppet Labs people to do this. But right now, the best way that I've found is to literally just write tests to assert state at a very high level. Specific things are working in this specific way, like these configs are in place on the machine, and doing a very kind of large acceptance test around that. I looked at Puppet acceptance early on, and it wasn't documented, but it is documented a lot more now. And so I'm hopeful that that sort of helps bridge the gap between making sure what gets out into production and what you would expect from the catalogs in production are correct. I think that's what you were talking about?
mostly, it's sort of a combination of it'd basically be like I have to write sub like tests for the specific modules, then tests for the node, like for the node or for the role definitions, and then on top of that, I'd have to add mocks to feed in factor and stuff like that.
Right.
So
I think the stuff with acceptance is actually really promising because I think there's some diminishing returns for mocking out a lot of stuff or trying to set up very specific integration tests. When I was doing a lot of the work preparing for this talk and kind of exploring some of these ideas, I found there's almost no substitute for just getting a machine stood up on AWS, provisioning it, and then checking the state. Like at the end of the day, that's going to be the ultimate test of what I want to see. With regards to the monitoring stuff, I have no answers there that would be useful. I've got a lot of bad ideas, and I don't want to talk about them because they're bad ideas. So I think we'll see something in the next 6 months around that.
I do think a lot of the auditing functionality that I think is in Puppet Enterprise, but I've never used myself, might sort of be what what you're thinking that might handle. But and the other thing was for the mocking, using PuppetDB to grab your catalogs and resources and stuff like that and feed it into. But I'd have to talk to Deepak about that.
There's some interesting discussion yesterday, kind of following Kelsey's talk, that got me thinking with the stuff that you can export from Factor or even dumping stuff out of PuppetDB. If you were to load that in with RSpec Puppet as fixtures, I think there's some really interesting things that could be done where if you just take a production environment that doesn't have any tests, if you can dump as much of that information as possible into YAML fixtures and then have RSpec Puppet load them, then you can at least get started with testing infrastructure after it's already been built out. But you should definitely find Tim and Ken Barber from Puppet Labs and talk at them about that a bit.
All right.
Thank you.
I'm in the middle of building out a pipeline for testing.
Cool.
And one of the things that came up this week at work was how to test different scenarios. So I need to support, as core infrastructure team, the various other app teams. One team wants to use a particular tool sitting behind Apache. Another one might want it just in raw Tomcat, et cetera. And I realized, well, gee, what I really need to do, I think, is stand up a VM, set up the manifest with just this couple of modules with these parameters, run through my unit tests, and then tear it down, set up another VM with a slightly different set of parameters with those manifests and so forth. And I might need a fan out with as many as half a dozen different scenarios.
Right.
So I wanted to hear some thoughts about setting up the wrappers around all of this unit testing that you're talking about and how to deal with both the simple unit test scenario where I'm only testing a single module in void or with just nothing but the base module list versus a complete system that is a web server or a database box or an app box.
So a lot of what I've been exploring, and all this Cucumber stuff that I've been talking about isn't just plain text nonsense. There's actual tests that I've put behind it. And so this particular example is up on GitHub. If you go under github/rtyler/red-green-example, I've done some of that. And the way that I've done it is exactly how you describe. I've been burning through money on AWS, testing things, just with these couple modules, throw those into kind of a test.pp, stand up a node, use masterless Puppet on it to run that module, and then assert the state of the world. If you've got enough money to go through sort of the matrix of things that you want to test or the combinations, it works out really well. And I've started doing this for a lot of different things to where instead of just saying include Apache, I would also do include Apache or SSH in one particular test, and then stand things up, make sure everything works correctly, and then that goes into one test file. And then go for, in some different combinations where maybe I throw Confluence in here, and then I need to test that. That would go into another test file. And so some of this stuff, it's just a matter of setting up the right tooling, and I've done some of it. I'm not sure how useful some of my code is going to be for everybody else, but it works out really well. You just have to have that sort of underlying framework in place that lets you kind of concocts a site PP or nodes PP on the fly, and then throw it on a machine and run Puppet on it. So yeah, it works out really well. You just have to kind of do the grunt work to get the underlying pieces in place. There's another guy back there, I think.
Yeah, hopefully.
Okay, sorry.
Oh, okay. You're probably almost done. One of the things that struck me as you were going through the RSpec Puppet is it seemed like you could almost copy the init.pp into your RSpec file, alter the syntax, and then you've got the RSpec tests. It almost seems like a literal duplicate. Where have you had variations and alterations beyond just basically testing the syntax of your init.pp's?
Where it's really come in handy has been with modules, and because I'm getting the hook. We can talk about this more afterwards, but I've had pull requests for modules that I've maintained that just added whole new classes into the module to support different systems or different flows, or just a params class that does a whole bunch of different things. And once you start to have a lot of variation, it becomes a lot clearer, I think, where RSpec Puppet can be really valuable. If you've only got like the one true system you're deploying on, it's not as clear how valuable it is. If you go through the test-driven stuff and you follow that flow for building things, I think it starts to make a lot of sense and it becomes really valuable there. You do end up having duplication in all testing. It's just a matter of where you find the value, and whenever I've broken something, I found the value in my tests. But I think I am getting the hook, so I guess thanks. I'm done. Yeah.
Let me just quickly. Yeah. All right, folks, before you split, just a few quick notes very quickly. First of all, since this was the last session, on behalf of Puppet Labs, I want to thank everybody for coming to PuppetConf 2012. This turnout was tremendous, and I think we've all heard a lot of really interesting stuff. Second of all, Zeke's tonight at 8:30 is the GitHub drink up, so please come and attend with the rest of us. And the last note is that the coat check is closing, which is why I was so rough on this poor guy. So you probably want to go head down and get your coats now, but please don't all trample each other on the way to do it. So thank you again very much, and good evening.